Hello, hello. Welcome to day 13 of our free cybersecurity training on YouTube. So on Wednesday we couldn't do a class. Nimeamua join the classes today. So today we're going to look at TCP/IP, and then tutakuwa tunaangalia encapsulation, and then tutakuwa tunaangalia pia the difference between TCP/IP and the OSI model. So by the end of today at least tutakuwa umejua what TCP/IP is na what encapsulation is and the differences between TCP/IP model and the OSI model. Alright, so let's get into it. What's up? What's happening? Siona. Okay, let's continue. So we are going to look at TCP/IP, the transmission control protocol / internet protocol. I'm going to explain what it is, the four layers, and the difference between TCP/IP and the OSI model. So what is TCP/IP? In previous lessons tulikuwa tumeongelea about TCP/IP. So hatuko explain kabisa, but I think tulikuwa tumesikia TCP/IP. So TCP/IP is the other model that we use for network communications. The other one we talked about was the OSI model, Open Systems Interconnect. Na tulisema OSI model iko na 7 layers. We have the application layer, the presentation layer, session layer, network layer, we have the data link layer, the physical layer, and all that. So we had 7 layers in total. But when it comes to TCP/IP, TCP/IP is the one that we use right now on the internet everywhere. So almost between TCP/IP and OSI model, the one that we are using is the TCP/IP. So that means it's very, very important that we understand the TCP/IP model, tujue the 4 layers, tujue each layer inafanya nini, and then pia tuangalie the differences between that and the OSI model. So what you need to know about the TCP/IP is that TCP/IP is very, very important. It is a set of rules that govern the entire internet, all right? So every device, vitu kama smartphone yako, laptop, everything, they obey the same rules so that data can travel safely between them, okay? So TCP/IP is the one that we use. Hivyo tu ndo nataka ujue. Iko na 4 layers, and we are going to look at the 4 layers in a short period of time. So TCP/IP iko na 2 core protocols, okay? Ndo maana inaitwa TCP/IP. So we have TCP/IP, and then we have IP on the other hand. So TCP stands for Transmission Control Protocol. It's a protocol of the internet. Na kazi yake itakuwa ni kuensure reliable delivery of data from one place to another. And then we have Internet Protocol addressing. Na kazi yake itakuwa ni kupatia addresses to every device so that they can exchange data or information. So just know that we have 2 protocols inside of the TCP/IP, and that is TCP and IP. 2 protocols. So TCP/IP was created by an organization called DARPA. DAPA stands for, I think it's a research, stands for Defense Advanced, I think, Research Projects Agency, something like that. Iko within the US military. Wao ndo walitengeneza the TCP/IP model, na just imagine this thing was created in the 1970s huko, and it is the one that we still use even today. Just imagine. So let's continue. Now you should know that TCP/IP matters a lot because it runs everything. Na nikisema it runs everything, basically wakati unatumia email, wakati una download something, wakati una watch movie online, you are using the TCP/IP. We don't use the OSI model. Tunafaa tujue hivyo. Sorry. We don't use the OSI model. The OSI model, it's what we call a conceptual framework. Yani itakuwa tu inatuguide. Itakuwa tu inatuambia vitu zinafaa kufanywa this and this and this, zitakuwa inafanyika like this, but in real sense hatutakuwa tuna follow hizo rules, ama hatutakuwa tuna apply hizo rules. Yenye tutakuwa tunatumia ni TCP/IP. Tafadhali tujue hiyo tu mpaka sasa. Sawa. So TCP/IP is used by almost 5 billion plus internet users. Just imagine. It was created in the 1970s. That was a long time ago. It is universal. Universal inamaanisha it is used by almost every device on earth. Iko ni Mac computer, iko ni Android, iko ni Windows, iko iOS, it doesn't matter. It is cross platform. That means almost every device on this earth inatumia TCP/IP. Okay, the other thing is TCP/IP itakuwa na 4 layers. We have 4 layers instead of the 7 layers pale kwa OSI model. Hapa tuko na 4 layers, and we are going to look at those 4 layers. The addressing versions that we use there is IP version 4 and IP version 6. So we have 2 types of IP addresses. That is IP version 4 that we are currently using, but it's almost running out. Sorry, Homer. And then we have IP version 6 that is going to take over after IP version 4. And then, just like we said in a previous lesson, we have a possibility of 0 to 65,535 TCP ports that we can use on the TCP/IP model. Okay, so those are just some of the key characteristics of the TCP/IP model that you need to know. It is used by many people. It is cross-platform. It has 4 layers. It was invented in the 1970s, and it uses IP version 4 and IP version 6. All right. So let's continue. So kama una to join sai, welcome again to our day 13, 4 layers, day 13 of our free cybersecurity course. So mvua inanyesha sana, hopefully tutamaliza poa. I hope mnasikia sauti yangu. You guys can hear me. Please comment hapo kama mnanisikia, if you can hear me. Day 13 of our I think sauti iko poa. So Caroline Waidero, good morning. Keter, good morning. Adan Mohammed, hi. Welcome to today's class. So we are combining Wednesday's class and Friday's class. Tumecombine hizo classes into one today. Haitakuwa a very long lesson, but itakuwa very very important regardless. Sawa. So by the end of today utakuwa unajua about the TCP/IP. Let's continue. So now let's look at the 4 layers. The 4 layers of the TCP/IP model. Now tulisema the OSI model iko na 7 layers. TCP/IP on the other hand iko na 4 layers. Tujue hiyo sahi, sawa? So we are going to look at the 4 layers one by one, at least ujue each layer itakuwa inafanya nini na itakuwa na kazi gani. This is very very important in case ukipata an exam ama ukipata a networking exam out there, right? So the TCP/IP is a 4-layer model, and each layer has one job, and then hands over that to the next one. Sawa? The same way with the OSI model. So hakuna difference mingi hapa sana, alright? So the 4 layers ni application, transport, internet and network access. Let's look at each and every one of them one by one. So you can think of the 4 layers of the TCP/IP model like a building, like floors in a building. So let's say tuko na kagorofa iko na floors in. So data starts at the top floor and then travels down to the ground floor one by one. So from the physical wire up to the end user mwenye anatumia your computer. Okay, don't worry, tutaongelea about that when it comes to data encapsulation. You remember last time nilikuwa explain data encapsulation, nikawaambia nitawa explainia in a later lesson. So we are going to look at that today. Na data encapsulation basically inamaanisha vile hiyo information itakuwa ina go down from the top layer down to the other layer hivyo, na vile itakuwa inashuka from those layers, information itakuwa inaongezwa kwa kila layer. That tutaongelea that in a very few. All right, let's first look at the 4 layers of the TCP/IP model. So at the top we have the application layer, just like the OSI model. All right, so hapa kwa the application layer we use protocols like HTTP, HTTPS, DNS, FTP, SSH, SMTP, Telnet. Zile tuko tumeongelea tu, zile common protocols, sawa. So hapa ni wakati unatumia kitu kama browser yako kubrowse kitu kama YouTube, internet, wakati una visit let's say kitu kama Gmail, ama you're looking up articles on the internet, wakati una send email, wakati una receive email, you are using the application layer of the TCP/IP model. So next up we have the transport layer. So unaona, we have the application layer on the OSI model, we still have a transport layer on the TCP/IP model and the OSI model. Just imagine. So hapa kwa transport layer ni vile tu inasema na itakuwa inafanya the same work na ile tu OSI model transport layer. It's the same thing, they do the same work, okay? And the same way pia we use 2 protocols, TCP transmission control protocol and UDP user datagram protocol. So tulisema tu ukisikia tu the transport layer ujue tu tutakuwa tunatumia protocols mbili, that is TCP and UDP. Tulisema tutakuwa tunatumia TCP kama tunataka a reliable delivery, si ndio? Tunataka kuhakikisha kwamba ile data yetu inafika pale na inafika in one piece na kila kitu iko in one place. Lakini kama tunataka tu information iende tu, hatutaki kujua kama itafikia ule mtu ama isimfikie, tutakuwa tunatumia nini? UDP. UDP is fast, TCP is slow. Alright? So transport layer itakuwa ina guarantee using TCP ama itakuwa ina speed up using UDP for data delivery. And then next up we have the internet layer. So the internet layer is a new one, si ndio? Pale kwa the OSI model tulikuwa na the network layer, layer number 3. But hapa tuko na internet layer. We're going to tutaongelea about that wakati tutakuwa tunaangalia the differences between the OSI and the TCP/IP, okay? So hapa kwa the internet layer, layer number 2 of the TCP/IP, we have IP version 4 and version 6. Tuko na vitu kama ISMP, Internet Control Messaging Protocol. Tuko na vitu kama ARP, Address Resolution Protocol, OSPF, Open Shortest Path First, and BGP, Border Gateway Protocol. So hizi zitakuwa zina find the best route. Zitakuwa zinaangalia ni barabara gani mzuri yenye hii data yetu inafaa kupitia ndio iweze kufika pale haraka and safely. Alright? So kazi ya internet layer ni kufind the best route for your data packets. And then the last one pale chini kabisa we have the network access. So unaona sasa hii pia ni mpya, si ndio? Pale kwa OSI model hakuna internet layer na hakuna network access layer, okay? Sawa. But we had data link and physical layer pale kwa OSI model. Sawa. But hapa kwa TCP/IP tuko na kitu inaitwa the network access layer. Na hapa tutakuwa tunatumia vitu kama Ethernet, vitu kama Wi-Fi, vitu kama MAC addresses, vitu kama PPP and DSL. So don't worry about hizo protocols zingine, tutakuwa tunaziangalia pole tu, don't worry. So basically hapa kwa network access layer, hapa sasa ndo ile information sasa inapita through the wires, zile cables kama ile Ethernet cables, ama zitakuwa zinapita through radio waves wakati tunatumia kitu kama Wi-Fi ama Bluetooth. Alright? So those are the 4 layers of the TCP/IP model. We have application, transport, internet layer and the network access layer. Na data itakuwa inatoka from the application layer, inaenda kwa transport, inaenda kwa internet, and then inashuka kwa internet, kwa network access. And then ikitoka kwa hiyo computer, hiyo information ikifika kwa ile computer nyingine, inaanzia pale kwa network access ikipanda juu. Network access, internet, transport and then application layer. Alright? So just know that we have 4 layers of the TCP/IP na ndo hizo pale. Let's continue. So kama uko na question as we continue, make sure unapiga pale kwa comment section pale kwa live yetu tukiwa tunaendelea. Good morning Elvis, karibu sana, welcome, tunaendelea. So make sure kama uko na swali piga pale chini, alright? Let's continue. So let's look at some of the protocols zenye tutakuwa tunapitia. So first of all, nataka tupitie hizo 4 layers of the TCP/IP model one by one, okay? 1 minute. I think sionekani mzuri kwa kamera. Wacha ni connect ka light kingine hapa. I think mnaniona mzuri sasa. Alright, let's continue. So what we are going to do now, we are going to break down the 4 layers, tuangalie one by one each layer, at least tuweze ku understand much better, sindio? So the first one tulisema ni layer number 4, the application layer yenye iko pale juu kabisa. Na just like the OSI model, layer number 7, the application layer, zitakuwa zinafanya the same thing, sawa? So hapa kwa layer number 4, this is you. So hapa utakuwa unatumia kitu kama browser yako, kitu kama email to connect, to interact with the network, ndio? So hapa tutakuwa tunatumia vitu kama HTTP kama tuna connect to a website, for example, labda you are connecting to YouTube ama you are connecting to labda another website, facebook.com ama something like that. Utakuwa unatumia HTTP ama HTTPS. Na tulisema HTTP ina run on port 80, HTTPS ina run on port 443. Okay? So kazi ya HTTP na HTTPS tulisema itakuwa ni kuload web pages in your browser. Basically kila kitu yenye unaona kwa browser yako, Google Chrome, Brave, Mozilla Firefox, ile kila kitu yenye unaona pale kwa browser, it is because of HTTP and HTTPS. Tujue tu hiyo ndo kazi yao, kuload hizo web pages. Ndio ikuoneshe kila kitu yenye kwa website, sawa? The other protocol yenye utakuwa unapata pale kwa application layer number 4 is DNS. Na tulisema DNS itakuwa inatumia port 53, na kazi ya DNS itakuwa ni kuconvert zile domain names, kitu kama google.com into an IP address yenye ile browser yako inaweza understand, ndio? So DNS itakuwa ina translate domain names like google.com into an IP address. The other protocol yenye utakuwa unapata on the application layer is FTP, file transfer protocol, and SFTP, secure file transfer protocol, sawa? So FTP itakuwa inatumia port 21, SFTP itakuwa inatumia port 22. Na kazi yao itakuwa ni kutransfer files between computers. Basically, wakati una upload something to the internet ama una download something from the internet, you are using FTP or SFTP, sawa? So basically SFTP is the more secure version ama is the secure version of FTP. FTP kivyake is not secure, that's why we have SFTP. The S stands for secure. So now the reason why nawapitisha hizi protocols is because unaweza ulizwa kwa exam, can you name at least 4 protocols that can be found on the application layer of the TCP/IP model? So you should be ready to answer. Alright? The other protocol that exists on the layer 4 application layer is SMTP, Simple Mail Transfer Protocol. Na tulisema hii itakuwa ina run on port 25 or port 587. Na kazi yao itakuwa ni kutuma email. Unaona wakati unaenda kwa Gmail, unaenda una type pale, una tap compose and then unatuma hiyo email, umetumia SMTP, okay? Wakati umetumiwa sasa from there, ndio sasa utakuwa unatumia nini? IMAP. Wakati mtu asha reply, hiyo message imeingia kwa inbox yako, ndio tutakuwa sasa tunatumia nini? IMAP ama Post Office 3, okay? Internet Messaging Access Protocol IMAP itakuwa ina run on port 143. Port 3 Post Office Protocol itakuwa ina run on port 110, na kazi yao itakuwa ni ku retrieve email from mail server to your device. Sawa? So kitu moja unafaa kujua, SMTP na IMAP na POP3 zote zinatumika kwa email, but SMTP ndio itakuwa inatumika kusend email, and then IMAP na POP3 zitakuwa zinatumika ku receive that email to your inbox. Alright, tujue hiyo difference. IMAP na POP3 hazitumiki kusend, kazi yao ni ku receive. Kutuma ni SMTP peke yake. The other protocol that you will find on the application layer of the TCP/IP model is SSH, Secure Shell. Na hii ina run on port 22. So SSH nime-explain mara mingi. SSH itakuwa inatumika wakati unataka ku control another computer. Ama let's say for example, you want to access a server somewhere on the internet. So there's no need for you to actually go. Let's say for example wewe uko Nairobi and then your server iko Kisumu. Hakuna haja uchome transport yako unatoka Nairobi unaenda mpaka Kisumu. In the real sense, unaweza kaa tu Nairobi na utumie kitu kama SSH na uconnect to that computer ama server, and then you can control that computer right from Nairobi thanks to SSH. So SSH itakuwa inatumika to securely access another computer, na itakuwa ina run on port 22. Now let's look at the next layer number 3, that is the transport layer. Na hapa tulikuwa tunatumia 2 protocols peke yake. Kuna protocols tu mbili kwa transport layer, both on the OSI model and the TCP/IP model. Na hapa TCP/IP tulisema ni transmission control protocol, na hii itakuwa ina ensure that we send data securely and reliably. Kama tumetuma information na hiyo information haijafika yote, TCP itahakikisha kwamba ile information yenye imebaki inafanya nini? Inatumwa pia pale. Yes. Alright. So if you want to send data securely and reliably, tunatumia TCP, okay? Na TCP hivi ndio itakuwa ina make a connection, alright? So we have what we call the three-way handshake pale kwa TCP, alright? TCP peke yake, not UDP. So unaona wakati tunataka to connect, let me show you something hapa. TCP 3-way handshake. So this is actually very very important. This is very very important. Wacha tuangalie image. Wacha tuone kama tutapata ka image ile simple. Kuna hii hapa ina ka simple. Ama Canva whiteboard. Wacha nionyeshe. I want to draw something. I want to draw something quickly here. I want to illustrate the three-way handshake. Ndio uone vile TCP/IP itakuwa ina make connection from one computer to another. Most of the time tunaitanga client and a server. Okay, come on baby, come on. Let's draw something here. Let's draw. All right. Where are my tools? I delete this. So let's draw. So first of all, let's say we have a computer here. So this is computer 1. This is the server. Sorry, this is the client. This is the client. The client is you. Wewe sasa. And then let's say you want to connect to a server. Na hii server let's say ni YouTube, ndio. So this is what we call a client server connection. So we have a client. This is you using your computer, and then we have the server, something like youtube.com. Okay, so TCP wakati kabla to make that connection, tutatuma kitu hapa, sawa? Alright, so first of all tuta make a request. let's say tunataka kuongea na computer yetu, the client inataka kucommunicate with the YouTube server. So let's say tunataka kuwatch video fulani, tunataka kuwatch video ya Cocomelon, something like that, let's say for example, ama tunataka kuwatch documentary. So the first thing yenye itakuwa ina happen, tunatuma what we call a CYN, basically synchronization message ama SYN. So basically ni kama tunauliza the YouTube server, hello, are you there? Okay, we are checking if the YouTube server is online, and then ile YouTube server kama iko online, ita reply to our computer hapa, alright? Ita reply na itasema, hey, I am here, niko hapa, niko online, unasemaje? So hiyo inaitwa SYN. Itatuma what we call a SYN plus ACK. SYN inamaanisha synchronization, and then ACK inamaanisha acknowledgement. We are acknowledging the request that was sent earlier, sawa? So hii SYN plus ACK basically ni ile server inaambia computer yako, hello, niko hapa na niko online, unatakaje, nikusaidiaje? And then the last thing that will happen, ile computer yako itatuma another, the last one sasa itatuma an acknowledgement, ACK. Okay, na hapo inasema okay, nimekusikia uko pale, si ndio? Hivi ndo nilikuwa nataka kukuambia sasa basically. So that is what happens. Just imagine. So this is the TCP three-way handshake. TCP three-way. Alright? Now this is very very important in computer networking. Lazima at some point utaulizwa about the TCP three-way handshake. Now the TCP three-way handshake basically iko like this. The first thing yenye tutakuwa tunatuma to the server is a synchronization message hapa. Basically we are asking the server, hey, are you there? Are you online? Can we talk? Ile server kama iko online, ita respond with a synchronization plus ACK. Flag, tunazitanga flags. Tunazitanga TCP flags, okay? So hii ni a bit advanced, unaweza enda uangalie TCP flags ni kama gani, kuna reset, kuna finish, hizo zote ziko pale. And then wakati server imetuma synchronization plus ACK, basically inaambia your computer, hey, niko hapa, niko online, nikusaidia aje. And then the last thing yenye itatuma is an acknowledgement to the server again. This is your computer sending to the server, inamwambia, oh nice, now this is what I wanted to say. Okay, so that is the TCP three-way handshake. Na inakaa something like this. Let me show you. So as you can see, this is the user, wewe, and then this is the server. You are sending, the first thing that utakuwa unatuma to the server is what you call a synchronization flag. Basically you are asking the server if it's online, if it's able to communicate. Okay, na kama ile server iko online, of course ita reply, itakujulisha. Na itarudisha message gani? Itarudisha a synchronization plus ACK. Okay, acknowledgement. Basically inaambia sasa ile computer yako, hey, niko hapa, nikusaidia aje. And then finally computer yako itatuma the last flag, which is an acknowledgement flag, ACK. Basically telling the server, oh nice, thank you, this is what I wanted to say. And then just like that, we have a connection established. Now the two computers can communicate. Sasa unaona, the purpose of the three-way handshake is to make sure that we make a connection to the server to confirm kwamba ile server iko pale na kila kitu yenye tutakuwa tunatuma to that server itaweza kureceive. Sawa, ni kama sasa mimi nachukua simu kwanza, ama nataka kuongea na wewe, but kwanza nitakuuliza, hey bro, ndakutext nikwambie, hey bro, are you there? And then kama uko pale utarespond, si ndio? Kama hauko utanyamaza. Kama uko pale utaniambia, hey bro, how are you? Umereply. That is a sync ACK. And then nitakwambia, oh kumbe uko online. Sasa tutapatana lini? So hiyo ni ACK nimekutumia tena. Now we have established a connection. So hii TCP three-way handshake is the reason why TCP is so secure, and it is also the reason why TCP is slow. It is slow because kuna hii process yote lazima ifanywe ndo tuweze ku make a connection to that server. So unaona, this is why TCP is slow. In the UDP hakuna process kama UDP, haijali, itakuwa tu inatupa kila kitu, sawa? So this is the TCP three-way handshake. I think nime explain. I think tumeunderstand, si ndio? So it's very very important. After this you can also go and look up, unaweza ufanye quiz ama ufanye exercises on the TCP three-way handshake. Alright, let's continue. So TCP transmission control protocol tulisema na those are the two protocols at the transport layer of the TCP IP model, TCP and UDP. So the three-way handshake inakwanga ni, first of all we send a synchronization flag to the server ina respond with a SYN plus ACK, and then lastly sisi ndo tuna respond with an ACK. So client ina send ACK to the server ina respond with a SYN ACK, and then client anatuma an ACK, and then we have a connection that is established. So when it comes to the TCP, when it comes to TCP, we have guaranteed delivery, packets arrive in order, we have error detection and retransmit. So the other protocol of the transport layer pale kwa TCP IP model is user datagram. Okay, so user datagram protocol tulisema it is very very fast. It is like shouting across a room. Ni kama unasema hey, habari kila mtu niaje, basically. Alright, so you just shout to every, utaki kujua nani ana receive your message, bora at least mtu mmoja asikie tu, yani you don't care. Okay, so you are like shouting across a room. Okay, so in simple terms tunapendanga kusema UDP is like fire and forget. Sawa, unatuma tu kitu na unasahau, utaki kujua kama imefika ama haijafika. So there is no delivery guarantee. Hatutakuwa tunajua hata kama imefika, hiyo data imefika to the other computer ama haijafika, we don't know. Si tunatuma tu. So it is unordered, packets may arrive jumbled. So labda kuna packets zingine zitafika, zingine zitakosa kufika, na UDP haitajali, haitashughulika hata kutuma tena hizo packets zenye zilikuwa zimefika. Kenya TCP sasa ingefanya, UDP doesn't care. Okay, we have low latency, it is ideal for real time. Latency tulisema inamaanisha nini? Hakutakuwa na delay, vitu zitakuwa zinaenda faster because we are not doing any error checking, we are not confirming if the data has reached the destination, we are not doing any confirmation. Sisi ni kutupa tu, so of course itakuwa very fast, hakutakuwa na latency. And then you will be surprised that we use UDP for vitu kama video calls, vitu kama gaming, DNS. Hata sahi we are like vile tuna live stream, we are using UDP. Alright, let's open Wireshark. Wacha tuone kama tunaweza capture hiyo traffic yetu right away. Alright, so now we are also using TCP. Wacha ni just imagine hivi vitu yote ni vitu zina. Why we don't have? Okay, strange. I thought we will see, but anyway, so we'll get more into Wireshark next week. Next week ndo tutakuwa tunafanya practical networking, and I think itakuwa tamu sana. Kwanza we are going to look at TCP Wireshark, ni kuonesha vile Wireshark itakuwa inatumika kuangalia hizi protocols za internet zote. So unaona vitu kama TCP ziko pale and all that, TLS, transport layer security, zile yenye inatumika kwa HTTPS, unaona yote inaonekana pale. So we'll look at all this in a later lesson. Alright, let's continue. So kwa layer 3 tumesema tuko na transport layer na tuko na protocols mbili, TCP and UDP. Let's look at the next layer, layer number 2, and that is the internet layer. Na kazi yake itakuwa ni IP addressing and routing. So every device on the internet has an IP address, like a house number that tells data exactly where to go. So hapa kwa layer number 2 tutakuwa tunatumia IP addresses. IP addresses kama gani? Kama IP version 4 na IP version 6. Okay, kuna two types of IP addresses. IP version 4 yenye tuko kutumia sai, but iko almost kuja. And then tuko na IP version 6 yenye imetengenezwa ku replace IP version 4. Okay, so hapa sasa kwa layer number 2 tutakuwa tunaangalia sasa the best path, ama ni wapi ile data yetu inafaa kupita ndio ifike kwa ile computer nyingine in the best way possible. So okay, so itakuwa like this. Hiyo information inatoka kwa computer yako inaenda kwa router yako, and then inaenda kwa router kwa the other side of the other network, and then inafika kwa hiyo server. Okay, So zile protocols zingine zenye unaweza pata pale kwa layer number 2 ni vitu kama ISMP. Don't worry about these protocols, just nataka tu ujue tu ni gani zinatumika hapa, but sitaki ati unaingia deeper into them, there's no need, alright? But just know that the most important protocol yenye itakuwa inatumika pale ni IP addressing ama IP addresses, and then tuko na vitu kama ISMP, vitu kama app, vitu kama OSPF and BGP, na vitu kama TTL, time to live. Okay, so I think vitu kama time to live, OSPF, open shortest path fast, vitu kama BGP, border gateway protocol, hizi tutakuwa tunaongelea more wakati tutakuwa tunafika pale kwa practical networking. Sawa, don't worry, usijiconfuse. Alright, so just know that kwa layer 2 tuko na the internet layer, na hapa sasa ndo IP addressing and routing. Basically inamaanisha hapa ndo tutakuwa tunaangalia the best path for our data packets to take. Ni barabara gani mzuri yenye tunafaa kuchukua ndio ile data yetu ifike pale kwa ile kompyuta nyingine vizuri. Alright, the last layer is layer number 1. It's called the network access layer ama the physical link. Okay, so hapa this is like the ground floor. Okay, this is the actual physical stuff. So hapa tutakuwa tunatumia vitu kama cables, Wi-Fi signals, fiber optic, light pulses. Okay, there's no intelligence, just physics and hardware. Okay, this layer gets bits from point A to point B on the same local network. So zile vitu tutakuwa tunatumia hapa ni vitu kama Ethernet, tutakuwa tunatumia zile cables, vitu kama Wi-Fi, radio waves and all that, vitu kama fiber optic cables na vitu zinaitwa MAC addresses. Alright, so hapa kwa layer number 1, the network access layer, hapa ndo sasa tutakuwa tunachukua sasa ile data na sasa tunaipitisha through the wires ndio ifike ama through the air ama waves ama through the fiber optic cables ndio itoke from that computer to the other computer. Okay, sawa. So the other important thing yenye tulikuwa tunafaa kuongelea is data encapsulation, na hii ni lazima niwa explainia because there's no way you can learn computer networking without understanding what data encapsulation means. Na data encapsulation ni kitu yenye utakuwa unasikia sana, especially wakati utakuwa una deal na the OSI model, TCP/IP model. I'm 100% sure at some point kwa labda ukienda interview ya IT lazima utaulizwa about data encapsulation. So data encapsulation in simple terms inamaanisha wrapping data with extra information so that it can be sent or used properly. Sawa. Alright, so in networking each layer adds its own wrapper, it's called a header. So this helps the data to reach the right destination and to be understood correctly. Okay, and then you can think of it like, you can think of data encapsulation. By the way, the opposite of encapsulation itakuwa ni nini? English. The opposite of encapsulation itakuwa ni de-encapsulation, of course. So encapsulation, we are adding information to those layer, to that data, vile itakuwa ina move from layer to layer. Okay, we are adding more information to that data. The encapsulation itakuwa ni the opposite. Tutakuwa tunatoa information information from those data vile itakuwa ina move through the layers. Okay, I think nimeongea French kidogo pale, but tutaangalia tu in a short while. So just know that in short, encapsulation inamaanisha putting data inside layers of information. Okay, na hiyo data yenye tutakuwa tunaweka inaitwa nini? Inaitwa header. Alright, let's continue. So I have a gram, I have a diagram, not a gram. I have a diagram here, wacha niwaoneshe. So okay, so wacha tuangalie data encapsulation kwanza on the OSI model, and then tuangalie the TCP/IP. Sawa, and then uta notice hakuna difference mingi sana between encapsulation in the OSI model and the encapsulation in the TCP/IP model. So first of all, if you remember, tulisema the OSI model iko na 7 layers. Ndio, we have application, presentation, session, transport, network, data link and the physical layers. Ndio, so even though ina happen at the application layer hapa, there is no hakuna information inaongezwa. Sawa, hakuna information inaongezwa. Actually encapsulation inaanzia hapa kwa layer number 4. Kwa layer number 7, 6 and 5 there is no encapsulation, okay? Tujue hivyo sahi. So at the application layer hapa, this is where the user interacts with the network. If you are sending an email, this layer handles the text and attachments, ile vitu utakuwa una attach pale kwa email, sawa? So it's writing the actual content of your message, okay? So hapa tuko na tu data peke yake, hatujaongeza anything kwa hiyo data, sawa? Hatuja add any headers ama hatujafanya any encapsulation, okay? Tujue hivyo, sawa? There is no encapsulation on layer number 7, layer number 6 and layer number 5 of the OSI model. Tushuke chini. Tukienda kwa layer number 6, tuko na the presentation layer. Na kwa presentation layer hapa tutakuwa tunafanya encryption and compression, sawa? So this ensures that data is in a usable format and is where data encryption, compression and translation occurs. So tukishuka chini we have the session layer, na tulisema session layer itakuwa kazi yake itakuwa ni kumanage the communication between applications. Kazi yake itakuwa ni kustart, kumanage and to end the connections. We call them sessions. Alright? And then sasa tukishuka hapa sasa ndo encapsulation inaanza. Sasa unaona? Kwa layer number 7 tuko na tu the data peke yake, what we call the payload. Kwa layer number 6 the same way, tuko na ile data payload. Kwa layer number 5 pia tuko na ile data. Hiyo data pia tunaitanga payload, sawa? But sasa tukifika kwa layer number 4 tunaongeza a layer 4 header. Alright? So data is broken down into segments. Alright? So tunaita segment sasa at this layer. So the layer adds a header indicating which protocol, TCP or UDP is being used and port number, sawa? So ile header inaitwa layer 4 header. Hii HDR inamaanisha header. Basically hii sasa ile layer 4 header yenye imeongezwa hapa kwa hii data ni hii header sasa itakuwa ina indicate kama we are going to use TCP ama UDP. Ndio ile sasa ile computer yako iweze kujua sasa are we going to use TCP ama are we going to use UDP. Hiyo itajua hivyo because of the header yenye imeongezwa hapa layer 4 header, sawa? Okay? So in this case sasa tukifika kwa layer 4 atuiti data tunaita nini? Segment, sawa? So kwa layer number 7, layer number 6 na layer number 5 tunazita data. Tukifika kwa layer number 4 it's called a segment, right? And then tutaenda chini to network layer. Hapa kwa network layer tulisema it's all about routing. Tutakuwa tunaangalia the best destination for our data buckets to take so that it can reach its destination. Now ukinotice hapa tumeka headers mbili. A layer 3 header and a layer sorry. Ile layer 4 header bado iko pale, sorry. So tumeongeza a layer 3 header, sawa? Na ile layer 3 header itakuwa ina contain sasa the IP address, okay? The destination and the source address. So basically sasa tunaambia sasa ile computer wapi sasa hii information inafaa kwenda, kwa the IP address of the target system, okay? So hiyo yote itajua because of this layer 3 header. Na tukifika kwa layer 3 atuiti data ama atuiti segment, tunaita nini? Packets. Okay? Tufike chini. Tukienda kwa the data link layer number 2, now you can see tumeongeza another header. Tumeongeza a layer 2 header. Na ile layer 2 header basically itakuwa inaongeza the MAC address, okay? So at this stage sasa tunaita nini? Tunaita frame. Atuiti packet ama segment ama data, tunaita nini? Tunaita frame. So the frame layer, it adds a MAC header for local hardware delivery and a trailer FCS for error detection. Remember, tulisema kwa data link layer na transport layer tunakuanga na error detection, okay? So in simple terms, tunaongeza a layer 2 header to indicate the MAC address ama ile address yenye itakuwa inatumika ndio tujue ni computer gani yenye inafaa ku receive hiyo information kwa ile network, the target, okay? And then lastly we have the physical layer, and the physical layer sasa hapa ikifika hapa ile data inaitwa bits, okay? So everything is converted into binary inamaanisha 1 and 0 and sent as electrical, radio or light pulses across physical media, sawa? So hapa sasa we are now transmitting the actual data and we call it bits, okay? So we are transmitting that information through the cables, Ethernet cables ama fiber optic cables ama radio waves when we are using kitu kama Wi-Fi ama Bluetooth, okay? So that is data encapsulation on the OSI model, okay? Tukiangalia on the TCP IP, okay, let's look at encapsulation on the TCP IP model. So utaona there is not much difference. So TCP IP tumesema iko na only 4 layers, not 7 like the OSI. So the first place tutakuwa tunaanzia ni application layer. Wario, enda cheza huko. So the first thing we have is application, na tunaita data at this stage. So we only have the application data, and this is where software like your browser or email client creates a request. This data is the payload that needs to be moved, okay? So hatuja add anything hapa. This is you interacting with the network through kitu kama browser ama email clients. And then tukitoka hapo, so hapa tutakuwa tunatumia vitu kama HTTP, DNS, SMTP, just like the OSI model. And then tukishuka chini now, tukienda sasa kwa the transport layer number 3. So hapa sasa is where we have end-to-end logic. Na just like the OSI model, tutakuwa tunaita hizo data nini? Segments. Okay? So utaona sasa tumeongeza a TCP UDP. Basically itakuwa ina indicate which protocol we are going to use to send that data to the other system. Okay? So kama tutatumia TCP ama tutatumia UDP. So data is segmented here. A header is added with port numbers, source and destination to ensure it reaches the right application on the computer. So, and then we have the internet layer. That is layer number 2 of the TCP IP model. Now utaona sasa tume add an IP header. Basically we have added an IP address to that data. Na hiyo data sasa inaitwa nini? Inaitwa packet. Haitwi segment na haitwi data. Inaitwa nini? Inaitwa packet, okay? So the segment here, layer number 3, the segment is turned into a packet, okay? Hapa kwa layer number 2. So tunachukua ile segment from layer number 3 and then we convert it into a layer 3 packet. And then an IP header is added with the source and destination IP address for global routing. So tunaongeza an IP address pale kwa the internet layer. So tutakuwa tunatumia vitu kama IP addresses, vitu kama ISMP, internet control messaging protocol. And then lastly, the last layer is the network access layer part of the TCP IP model, and this is just like the physical layer on the OSI model. Hapa sasa the packet from layer number 2 is wrapped in a what we call a frame. MAC addresses are added for local delivery, and then it's converted into electric signals, that is bits. So hapa tutakuwa tunatumia vitu zinaitwa frame and bits, okay? So we have 2 there. So this is what data encapsulation looks like in the TCP IP model. So at the application layer tuko na only the data. Tukikuja kwa transport tunaongeza TCP and UDP header. Tukifika kwa internet tunaongeza IP address header and TCP UDP, and then tukifika kwa network access tunaongeza a MAC header, an IP header and a TCP, and then hii information sasa inatoka from this computer inaenda to the other computer. Okay? So that is what data encapsulation looks like. Okay? Sawa. So okay, hiyo tumeangalia hiyo. So now I think the most important thing sasa ni kuangalia the differences between TCP IP na the OSI model. So I think tumeongelea a lot about the OSI model, cover a lot. Tumeongelea about TCP IP model leo. At least tumejua TCP IP model iko na 4 layers. We have the application layer, we have the transport layer, the network layer, the internet layer, and the network access layer, okay? 4 layers. So what I want us to do right now is to look at the differences between the TCP IP model and the OSI model, at least to do what are some of the key differences, and ndo tuweze distinguish between the two, alright? So first of all, let's look at the OSI model again. Ndo mimi nilikuwa nakwambia, don't worry, in the previous lessons tutakuwa tunarudia hizi vitu so much that itakuwa tu inaingia tu kwa kichwa tu bila kupenda, okay? Don't try to cram anything. Unaona, tutakuwa tunarudia hizi vitu because in cybersecurity vitu zitakuwa zinajirepeat almost all the time, especially in networking. Tutakuwa tunaangalia OSI model everywhere. So at the end of the day akili yako itakuwa tu inaabsorb tu, don't worry, alright? So hii ni kama tu summary again, just a recap, okay? So the OSI model was created in 1984 as a universal reference standard. The key word here is reference. So inamaanisha tutakuwa tu refer to this model, but in reality hatutakuwa tunatumia the OSI model, okay? So you can think of it as the theory textbook, okay? It's not used directly, but it explains how networking works at every level. So kitu unafaa kujua ni tunatumia TCP/IP right now. Everything on the internet in the world inatumia TCP/IP. We don't use OSI model. So tulisema OSI model iko na 7 layers. We have the application layer, na hapa tutakuwa tunatumia protocols kama HTTP, FTP, DNS, SMTP, SSH, and this is basically is where you interact with the applications, vitu kama browser, vitu kama email. And then next up we have the presentation layer, layer number 6, and this is where we have vitu kama TLS, transport layer security, SSL, secure sockets layer. We have JPEG, ASCII, encryption. So basically hapa tutakuwa tunakuwa na formatting and encryption and formatting of data, and encryption also, translation yote ina happen pale kwa layer number 6. Pale kwa layer number 5 we have the session layer. We have protocols like NetBIOS, RPC, SQL sessions. Na tulisema the work of the session layer is to start, to manage and to end connections, what we call sessions, okay? Layer number 4 is the transport layer, na hapa tuko na protocols tu mbili. We have TCP and UDP. Kama tunataka reliable delivery tutatumia TCP, kama tunataka tu kitu fast tutakuwa tunatumia UDP. And then we have layer number 3, the network layer, na hapa tutakuwa tunatumia vitu kama IP, ISMP, OSPF and BGP. Basically the work of the network layer is to find the best path for your data packets. Itakuwa inaangalia ni barabara gani mzuri ile data inafaa kupitia. And then next we have data link layer. We have kitu kama Ethernet, MAC address, ARP, and virtual LANs. We'll talk about VLANs in a later lesson because it's also very, very important. Okay? So VLANs ina stand for virtual local area networks. Basically ni vile wakati tutakuwa tuna break up networks into different parts, okay? That is a lesson for another day. So data link layer itakuwa ina deliver the information to the right device in the local network. And then we have the physical layer. Vitu kama cables, Wi-Fi, fiber, Bluetooth yote inapatikana hapa, and this is the actual wires and signals, okay? Now let's look at the TCP/IP comparison sasa, side by side, okay? So as you can see, the OSI model iko na 7 layers, TCP/IP iko na 4 layers, okay? So the application, presentation and session layer of the OSI model imewekwa into one layer of the TCP/IP model. That is the application layer. Sawa. So application layer ya TCP/IP model imechukua the application layer, presentation layer and session layer ya OSI model na ikaweka into one layer. Sawa. So hapa ni HTTP, DNS, SMTP, FTP, SSH. So ile vitu yote inafanyika kwa application layer, presentation layer, vitu kama encryption, session layer, managing sessions, yote inakuwa handled by one layer of the TCP/IP model, that is the application layer. Sawa. And then tukikuja hapa, transport layer bado ina exist pale kwa the TCP/IP model. Bado inaitwa transport, na bado tuko na 2 TCP na UDP. And then tukikuja kwa layer number 3 ina convertiwa to something called the internet layer, na it is the same, iko na the same function tu. Itakuwa inaangalia the best path for your data packets, okay? And then sasa hapa kwa layer number 2 na layer number 1 of the OSI model, data link layer na physical layer zimeconvertiwa to one layer, that is the network access layer of the TCP/IP model. So the network access layer imechukua data link na physical layer from the OSI model na ikaweka into one layer called the network access layer. So ile vitu zote zenye zinafanyika hapa, error correction kwa data link, vitu kama physical pale, everything that happens there zinafanywa na one layer of the TCP/IP, that is the network access layer. And some of the key differences between OSI model and TCP/IP, OSI model iko na 7 layers, TCP/IP iko na 4 layers. The purpose is theory, OSI model is theory, TCP is practical. That means OSI model itakuwa tu inatusaidia ku understand networks, but in theory, in reality hatutakuwa tunaitumia. When it comes to TCP, it's practical. That means tutakuwa tunatumia hiyo in real life. Sorry. When it comes to the year that was created, OSI model ili creatiwa in 1984 na TCP/IP ili creatiwa in 1970s. The OSI model is a reference model, TCP is the real internet. And then okay, kuna other differences like layer 3 jina ni network, kwa OSI ni network, kwa nini TCP/IP ni internet. At the same time application presentation session from the OSI imewekwa into application, and then data link and physical zimewekwa into one network access in the TCP/IP model. Those are just some of the differences between the OSI model and the TCP/IP model, and I think this is very, very important for anyone in cybersecurity to be able to understand this. Okay, all right, so these are just some of the key takeaways. Tumejua what TCP/IP is, na tumejua the TCP/IP is a 4-layer system, na it is the one that we use on the internet and our everyday life. Okay, it has 4 layers. We have the application layer, we have the transport layer, the internet layer, and the network access layer. And tumeangalia the differences between the OSI and the TCP/IP pia. Okay, sawa. Na pia tumeangalia what encapsulation is, na tumesema encapsulation itakuwa ni wakati tuna add information to the data as it moves through the layers of the OSI model or layers of the TCP/IP model. Na vile hiyo data itakuwa ina move from the layers, itakuwa tunaongeza information, what we call headers. Okay, na I think unaenda research more about the encapsulation. Na the opposite of encapsulation is de-encapsulation, wakati tutakuwa tunatoa hiyo headers from that data. Okay, wakati imefika kwa ile the other computer now, right? So I think that was a quick one. Sijui kama kuna any msea kona Edwin anauliza, data encapsulation, does it work like capsule drugs? I know it's a crazy way to think of it, but it's the same way. Vile hiyo dawa inapita pale kwa factory inaongezwa ndani. I think it's a funny way to think of it, but it kind of makes sense. Yeah, it's the same thing. All right, I think leo tume understand what data encapsulation is, na tumejua the differences between the OSI model and the TCP/IP model. So next week we are starting practical networking. Tutakuwa tunaangalia how to use things like Wireshark. Tutakuwa tunafanya a bit of port scanning using something like Nmap, the network mapper. So tutakuwa tunatumia Kali Linux to do some of the things that we'll do at that time. So asanteni sana, naona there are no questions. I think it was a good one. Tumeenda poa. So if you have any questions, bado unaweza piga pale kwa Telegram. And then I think next week we'll have something. We are going to work on the digital skills course. Basically, kama kuna mtu ajui kutumia computer ama ujui mambo na hardware, software, operating systems, I'm working on a course. Na nitaweka tu pale kwa YouTube bado. So itakuwa ni digital skills training basically for anyone who doesn't know how to use a computer. Okay, so thank you guys, thank you for joining this lesson today. Now I will see you guys on Monday, God willing. But remember, we can always interact pale kwa Telegram if you have any questions. Okay, so thank you again and see you in the next one. Cheers. Every day is a learning day.